In this particular topic, we will be learning about the bubble sort. So in the case of bubble sort, you can see something like that. You want to throw one stone somewhere and you want to throw it to the maximum, right? Till that, so that you can say you are reaching to the highest point, something like that. So by using this concept, you can apply this concept in the sorting part also. So in this case, if you can see here, suppose you have an array of data which is in unsorted order and you want to do sorting of that. So you want to start traversing from the front and you want to send the largest element because we want to sort the array in the ascending order. That's why we are talking about here in the largest item. So we want to find the largest item and I want to move that item to the top, or you want to move to the at the last position here. Then in the next iteration you will be finding the next largest element, like that you will be traversing the complete array. Okay, so starting with the first item, assume that that is the largest item. Then if the first is larger, then you will swap the two. Otherwise, you will be considering the second item as the largest item. So it will be continue up to the array. So there are three versions of the bubble sort. I'll be discussing about each and every one by one. So after one pass, you will get the largest item that must be sent to the last. So you need to run till n minus 1 time. Suppose array contains n element. So at most you need to repeat this particular pass up to n minus 1 time. Okay, so you can see in this example that this array is in unsorted order. We just swap consecutive elements. So here you can see this one is my unsorted array. You will start from the first element. You will swap these two. So 7 is less than 14. Swapping is not required. Now you will compare these two again. So this one I'm talking about pass 1 only. So now these two are compared. Now you can see here 12 and 14 will be swapped. Now 33, 5 and 19. Now 14 and 33 will be compared. So 14 is less than 33, no swapping is required. Now 33 and 5 will be compared here. Now you can see here how many, will there be any swapping? Yes, swapping is required. Now in the next iteration, 19 and 33 will be compared and you can see 33, we are getting the largest element. So how many iteration in pass 1, how many iteration or how many swapping or not swapping we are needed to do? So you can see 1, 2, 3, 4, 5. 6 elements are here and we needed to swap 5 elements, that is n minus 1 element. This one is my pass 1, but after pass 1 the array that we are getting is not in the sorted way. So what we need to do? We need to do sorting again. So maximum number of time that you need to run this passage again n minus 1 time. So element is 6 here, so you need to run up to pass 5 maximum time. Well, like when you are considering it in a no matter. So now you can see 7, 12, 14, 5, 19 and 33. So what you are doing? You are checking these two. So these two does not need to do any kind of swapping. Now you will consider these two, no swapping, 5, 19, 33. Now you will compare these two, swapping is required, 7, 12, 5, 14, 19, 33. Now you will consider these two, 14 and 19, no swapping is required. Again you need to write it like this, 5, 14, 19, 33. Now you will compare these two. So no swapping is required, but still you need to write like this because we are considering in like we don't know anything about this particular searching and sorting part. Okay, this one is pass 2. Now coming to pass 3. So after pass 2, my array element are like 7, 12, 5, 14, 19 and 13. Now after pass 3, you will get some array. Similarly, we'll go to pass 4 and pass 5. But this one is the worst case thing. So if you consider the algorithm for this one, so you will repeat this process until pass 1, pass I and cross this time. So if I just want to write the algorithm here, this one is this loop for the pass and this loop for swapping the two adjacent element. So both the loop you can see here is running up to n-1 n-1 time. So this one is worst case complexity will be O(n) square. But in the previous case, when we saw there, we can see when we did the first pass, we knew that first and second pass, right? We knew that we got the element something like 5, 14, 19 and 33. We knew that these two are already sorted. So we need not to go up to this part. Why we wanted to repeat these two steps in this particular for loop? So inside here, going up to n-1, what we can write in the loop? We can write n-i-1, optimized case. So after 0th iteration, in the case of 0th iteration, you will go up to n-1 time. But in the first iteration, when the value of I is 1, you will go up to n-i-1. That is 6 minus 1 minus 1, right? So that will be going up to 0 to 4 passes. So it will skip this part and this part in each iteration. So you can see here you have optimized your code little bit, right? Because you know this element is the second largest, this element is the first largest element, right? So with this loop, 5 and 7 are swapped, you can see. So like this you can, so if you just write the optimized algorithm to here, the second loop is running little bit lesser in the first case that I discussed earlier. Now I want to make it optimized again. Suppose I'm just running this into multiple passes, but here no swapping is done in each and every pass. For multiple passes, there is no swapping. So if there is no swapping, that means my array is already in sorted order. So why I am performing this step? So what we can do in this case, if in any pass I came to know that there is no swapping, then I can set the flag bit as a no swapping as a 1. So in that case, if that flag bit is set as 1, so in that case we can say my array is already sorted and I can go out from this loop, or I can break this loop, right? I can halt the loop. So okay, so you can see here, so if I consider the thing here, there are 10 elements, right? So this should be, the passes should be go up to 9, right? So up to 9 passes, it will go. So outer for loop will go up to 9 time, and inner for loop will be going up to n minus I minus 1 time, right? But you can see after pass 1, 2, 3 and 4, I came to know that my no swapping is done, right? From this onward, there will be no swapping. So if there is no swapping, why I am running till 4 to 9 passes, right? Because I know my array is already in sorted way. So what I can do, I can set a flag bit to go out from this particular loop. So if you just see this previous algorithm, so this one is till my passes, right? I am setting flag bit at 0, right? So if any of the swapping is done, right, this flag bit will be set as 1. So if flag bit is set as 1, you will go inside this for loop. But once this flag bit is 0, right? So in any of this particular, so this one is the closing of this for loop, right? So in one pass, you have performed swapping operation and you came to know flag bit is not set as 1. So in that case, what you will do? You will go after this for loop, you will check this condition whether flag is equal to 0 or not. If flag is 0, that means no swapping, and you will break from here and you will go out from this outer for loop also, right? So like this we will optimize our bubble sort algorithm. Okay, so you can consider here best case and worst case scenario, right? So in the best case scenario will be we are not running this particular inner loop, right? Our array is already in sorted order, means no swapping is done. In that case, in the best case scenario, the time complexity will be n, and in the worst case scenario it will be n square, because here it is going to n minus 1 time and this one is going to n minus I minus 1 time. So in the worst case it will take n square time, but if your array is in already sorted order, in that case this particular for loop will not be executed and you will be not running your loop inside this one, means there is no sorting is performed and your array is already sorted. So like this one was bubble sort algorithm I discussed about in this particular topic.